This video, we're going to go over 5.5 in the book and then some examples from part 1 and part 2 of the homework. So, part 1 of the homework is using the indefinite integral. So, the substitution rule is when you have a function that is a composition involving another function. So let's just look at this example here. I couldn't do this. I could expand this out and use the power rule, or I could just let u equal 2x plus 1, and then du would be 2 dx. So I take the derivative of u on the left-hand side and the derivative of x on the right-hand side, and this dx is very important. This dx then can be written as dx is du over 2. So that can be replaced with this dx. And then you end up with the integral of 2 times u cubed times dx. You want to write that in terms of du. So in this case, the 2's are going to cancel, and you're going to end up with the integral of u cubed with respect to u. And that is very straightforward with the power rule to put u to the n plus 1 over n plus 1 plus c. But this is in terms of u. You want to get it back in terms of x, so you're going to use this here, and you would have 2x plus 1 to the 4th power divided by 4 plus c. And if you differentiated that, you would end up with what you have here. Let's look at a little bit more complicated one maybe here. You're going to, the inside of what's in parentheses, you're going to pick that to be u, which is going to be convenient because you're going to be able to cancel this x to the 4th that's here and just get a function of u. And they do that here, is they let this u be u. So you end up with finding du, which du is 5x to the 4th dx, solving for dx, and here they group it so that they're going to just cancel this 4x and this dx. They're going to just substitute that with 1/5 du. I kind of like to see it where I would have the integral of u to the 9th. If I have x to the 4th, then I'd have 1 divided by 5x to the 4th du. And then I see how those x to the 4th cancel. And I'm left with this. So pretty straightforward again. Here's another example where I can take, this is one like that's on the homework, this example 3 that's in the book. Similar idea as this, I let u equal x plus 1, but then I can manipulate that u to solve for x. And when they do that here is, when I take the derivative, I get du, so that's pretty straightforward. But how do I cancel out this x in the numerator? Instead of canceling it out, I solve for what it is in terms of u. So I end up with something like this. And then I'm able to just rewrite the integral and use factorial powers to integrate that. And that's shown there. So those are common examples of things that might come up. Something like this is, I could go about this and substitute it. And then the second part of this is when you change the bounds of integrations, and that's going to be the definite integral. And that's going to be when you have this a and this b. So there's kind of two ways to do it. You can always write it back in terms of the original variable x and use the original bounds, or you can change those original bounds and use the function of u, and you would have these new bounds. So let's look at an example here. This a goes about it does a u substitution, and you notice here it does u, it changes the bounds of integration. Here, if you let u equal x plus 3, then when x is 0, then u would be 3. When x is 2, u is going to be 2 plus 3, which is 5. So my bounds of integration change from 3 to 5, and then I can plug that in my function of u. So typically we use the bounds of integration changes. We don't necessarily have to go back. If we did here want to say 1/3 ln of the absolute value of x cubed minus 7, I could then use 2 and 3. So this is in terms of x. I use the x bounds. These are the x bounds. But if I want to use the u bounds, I have to use the function of u. So one thing, common mistake here is not changing your bounds of integration. Here's an example of some that come up in the homework. Picking u to be sine of x. So then du is cosine of x dx. So I have that cosine of x dx. I can just replace that with du. But I want to change my bounds of integration. So when x is 0, sine of 0 is 0. When x is pi over 2, sine of pi over 2 is 1. So now I'm using a much easier integral to deal with. And that's the whole point of doing u substitution, is you're simplifying the integral by picking a key substitution to make it easier. On part 1 of the homework, you will just write out the definite integral or indefinite integral. Part 2 of the homework, you're going to plug in your upper and lower bounds. So